Hello everyone. In this session of CCNA series, I'll discuss about host, IP, parameters, and verification. Every host that uses IP needs to have some settings to work correctly. To work correctly, an IP host needs to know these values. Device's own IP address, device's own subnet mask, default gateway or router IP address, DNS server IP address. Each device needs its own IP address and subnet mask. Each endpoint needs to know the IP address of a router that resides in the same subnet. The endpoint uses that router as its default router or default gateway. The host must know the IP address of one or more DNS servers to send the server's name resolution request. For enterprise, the server may reside in the enterprise as shown in the figure. The host typically knows the address of at least two DNS servers for redundancy. If the first DNS fails to respond, the endpoint can then attempt name resolution with the next DNS server. Let's see how we can verify those IP settings on three of the most commonly used OS: Windows, Mac OS, and Linux. Let's see how we can verify the host IP settings on Windows. The more common OSs people work with every day have a fairly easy to reach settings window that lists most, if not all, the IP settings in one place. For example, let's take a GUI display in which the network configuration screen from a Windows 10 host from the network area of the Windows control panel. This particular example shows the big four settings, that is address, mask, router IP, and DNS. However, beyond the GUI, most OSs have variety of networking command available from a command line. With all Windows version, the ipconfig and ipconfig/all command supply the most direct help as shown in the figures. As you can see, both list the address, mask, and the default gateway, with ipconfig/all command also listing the DNS server settings. Another common command on the most user host OSs is the netstat-r command. This command lists the host IP routing table. Of interest, the top of the table lists a route based on the default gateway and the destination subnet and mask listed as 0.0.0.0. The top of the output also lists several other routes related to having a working interface, like a route to the subnet connected to the interface. Note that the gateway of on-link means that the PC thinks the destination is on the local subnet. Let's verify the host IP settings on Mac OS. Like Windows, Mac OS has both a graphical interface to see network settings and a variety of network commands. To check the IP settings in Mac, these items can be found in the network section in System Preferences. In the example, figure shows the network setting in Mac OS for an Ethernet interface with address, mask, default router, and DNS server addresses. Also note, the setting states that the interface is using DHCP. Mac OS and Linux both support the ifconfig command to list information similar to Windows ipconfig/all command. Note that the ifconfig does not have an /all option of note. Of note, the ifconfig command does not list the default gateway or DNS servers. So example includes two other Mac OS command that supplies those details. Like Windows, Mac OS adds a default route to its host routing table based on the default gateway, as well as a route to the local subnet calculated based on the IP address and mask learned with DHCP. And like Windows, Mac OS uses netstat-rn command to list those routes, but with several differences in the output. Of note, in the Mac OS sample shown in example, the output represents the default route using the word default rather than the paid number 0.0.0 for destination, subnet, and mask. Let's verify the host IP settings on Linux. On Linux, the graphical windows to display network settings differ for many reasons. First, the Linux world includes a large number of different Linux versions or distributions. Additionally, Linux separates the OS from the desktop so that a user of one Linux distribution can choose between different desktop interfaces. As a result, you will see different GUI screens to display the Linux network settings. This section shows a few examples from Mate desktop included in the Ubuntu Mate Linux distribution. It shows the details for a wireless LAN adapter and includes the IPv4 address, mask, default router, and primary DNS IP address. From the command line, Linux host will often support a large set of commands. However, an older set of commands reference together as nettools has been deprecated in Linux, to the point that some Linux distributions do not include nettools. The nettool library includes ifconfig and netstat-rn command. To replace these tools, Linux uses the IP route library, which includes a set of replacement commands and functions, many performed with the IP command and some parameters. Example shows a sample of the ifconfig command if it lists the Ethernet MAC and IPv4 address along with the subnet mask. It also shows some interface counters. For example, it shows the command from the IP root package that replaces ifconfig, namely the IP address. Note that it shows the same basic addressing information just with the subnet mask shown in the prefix notation rather than in the dotted decimal. Linux has long supported the netstat-rn command as well. As part of the nettools package with the sample shown in the example, the output lists a default root but with a style that shows the destination at 0.0.0.0. As usual, the default root points to the default gateway as learned with DHCP 192.168.1.1. It also lists a route to the local subnet 192.168.1.0 as highlighted toward the bottom of the output. Example shows the command meant to replace netstat-rn IP route. Note that it also shows a default route that references the default router along with a route for the local subnet. That's it for this session.